In this episode, we're going to be covering pinned rebate boxes. Before I get started talking about this box, I actually want to talk about the next box. While this is a fairly good pinned rebate box, the next one will be a hand-cut dovetail box because that's what my wife has requested. She has a specific use for a box, specific dimensions, and I've got to tell you that it's all nice and good to have these test boxes that I'm improving on joinery and showing things off and all of that, but to have an actual purpose for a box before it's even begun is just, icing on the cake. It really motivates me to work on that. That won't be the next video. The next video will actually be on the moccasin vise I'm making to then make the dovetail box, because that'll help with cutting the joinery and getting everything to fit. So I'm very excited to share that one next. But onto this box. I've milled all my material for the sides up. I haven't done the base and top just yet. They are 180mm long for the shorter pieces and 300mm long for the longer pieces. Height is about 130mm. It doesn't really matter, these were just random numbers pulled out of my head. And the thickness is 12mm for two reasons. The first is I kind of forgot to thickness it down any thinner before I cut it up, and these are now a little bit too short to go through the thickness of. It's fine, doesn't really matter. The other reason is that rebate joints are just butt joints with delusions of grandeur. They have no real mechanical strength at all, so we need to reinforce that. Whatever we're reinforcing that with, we need to take its diameter into account. So I'm going to be using either 6mm diameter wooden dowels or brass dowels. So I need to have a little bit more material to be able to drill into. I have a sample cut. You can see there's no mechanical aid to keep these parts together until we come back and add a dowel. So this is that 6mm dowel. So if the material was any thinner, it just wouldn't get a good hold on it. And I'd have to step down to some thinner stock, which would absolutely be fine. The brass is going to be more than strong enough once it's glued in. But again, just something to keep in mind. I'll be using both the router table and the table saw to cut these rebates. There are pros and cons to both methods of doing it, so I'll go over those. Using handheld power tools like a router or I guess a circular saw, not really the best choice for something this size. There's just not enough surface area for the tool to rest on to get a nice, clean, repeatable cut. Obviously, you could make a jig to hold this so that you can, but I'm not going to be covering that in this episode. For this box, I'll be starting at the router table to demonstrate how to cut the rebates at the router table, but we still have another choice. Which of these three bits is the best option for us? And the honest answer, it kind of doesn't matter. A larger diameter rebate bit like this is fairly inexpensive. They'll make fantastic rebates, but at a router table, the bearing doesn't really help us or even hinder us. It's just a wide cutter. It'll work just fine. It may perhaps change how tear out happens because of the geometry, but it'll work just fine. We've got a spiral upcut bit, which is a 1/4 inch, and we've got a 1/2 inch straight bit. Between the two of them, the 1/2 inch straight bit will win every time because we're cutting a 1/2 inch rebate. And ideally, we don't want to move the fence at all, but we will graze and lower the bit. Between the two of them, if they were the same diameter, really either's going to work. The straight bit may, again, provide slightly better tear out. As we're not plunging, we're not going to get the benefits of the chip extraction that spiral upcut bits have. You may get slightly more of a shearing cut, so that might produce a slightly better result, but it's much of a muchness. So I'll be using this straight bit, but any of these three types of router bits would work just fine, assuming that they are wider than the rebate that we want to cut. I've got the fence set up just in line with the end of the cutter. It would actually clip the fence just a hair, so that's why I have the split fence open. It'll also increase dust collection. The bit itself is set using this setup block. This is a 3mm setup block. That's how much I want to take off per pass. So I'm just going by feel there, and I can feel that that's slightly over. So I'll be pushing my workpiece through like so. Maybe a little bit too much per pass, we'll see. This is just a test piece, and this will show the sort of tear out we'll get if we don't do anything to mitigate it. There's a pretty small amount of tear out, but it does exist on the trailing edge. Otherwise, a very clean cut. So this is because there is no support for the fibres at the end, and the particular direction of that cutter relative to the orientation of the workpiece means that it blows out on this very short edge here. So there are a few ways we can reduce or eliminate tear out. Some of them are a little bit more viable than others. First off, we could use a cutter with a shearing angle to it, so that may be less prone to tear out. Sometimes is, sometimes isn't. But using this cutter, we've got a couple of ways. First is you could just chop that part off. So for example, you could have your workpiece oversized, cut the joinery, then just take off a couple of millimeters, get it to its final size after you've cut the joinery. May or may not be a viable option. Another way is having a support piece, sacrificial piece at the end. So we'll pretend this piece here is our sacrificial piece. It will go through the router at the same time, and this will create a zero clearance edge because it's cutting into the sacrificial piece, so those fibres are supported. That works incredibly well and is perhaps the easiest way because you can just use any scrap you've got laying around so long as where it's going to be cut is not cut through on the sacrificial piece. It doesn't have to be a particularly hardwood, softwood, plywood, MDF, whatever. That'll all support the fibres. Table saw is pretty self-explanatory after going to the router table. We've got a miter gauge. On the miter gauge we've got a sacrificial fence here as well. And I've already taken the cut out of where the dado stack will be. This is set up for a 1/2 inch or 12.7mm dado stack, which is about the thickness, slightly over the thickness of the workpiece. This is what we'll be cutting away. Zero clearance on this means that we won't get tear out, so that's not something we have to deal with. Now, personally, I still think using a crosscut sled with a zero clearance insert is better than using a miter gauge for these type of cuts, but you'll get pretty much the same result so long as you've got a fresh zero clearance insert on your miter gauge. One major difference with the table saw compared to the router table is that you can pretty much take the whole chunk off at once. You might want to do a finishing pass, but on the table saw you can pretty much do the whole pass and it's not going to bog down or be problematic with the cutter because of the extra mass and potentially the extra power of the motor of your table saw. That's going to depend on your exact configuration, induction motor and universal motor, blah blah blah. So I'll do a test cut on this, but if I'm being perfectly honest, I prefer to do these type of cuts at the router table. It's, for me, a quicker setup and you get pretty much the same result. I feel like I've got a little bit more control at the router table, but again, the results are going to be the same, so it doesn't really matter. It's whatever your personal preference is. For the base and the lid, I'm just going with the simple floating panel. That's not the focus of this video, so I'm not going to go overly complicated on that. To create the grooves for the floating panel, I'm just going to use a dado stack because I've just used the dado stack to cut the joinery. Single blade, router, bit, whatever, we'll do the same thing. It's just a through groove, and that's the neat thing about the rebated joinery. So long as we don't have the groove deeper than the rebate, we can do a through groove because the end piece will hide that groove and the side pieces hide the groove for the end piece, so nothing's exposed, so we don't have to worry about doing a stopped groove. So I will be going with wooden dowels instead of brass because the brass is expensive and this will look just fine. On your wooden dowels, and I suppose your brass as well, make sure that you check the diameter. I've got 3 of these 6mm dowels and 2 of them are 6mm on one side and on the other they're about 5.5, so they've gone slightly elliptical, which means you get a bit of a gappy fit, which isn't the end of the world. You can definitely fill that with filler or sawdust or whatever, it doesn't really matter. But it is something to be aware of. It can be quite frustrating when you've got the right size drill bit and you've got the right size dowel, but why is there gaps? It's usually because the dowel is out of shape. Sometimes they'll be a little bit under or oversized, so check that beforehand. The best way to do that is get a scrap piece, drill a hole in it, and check the fit. So I'll be using Vic Ash dowels, just like the boxes Vic Ash, and because it'll be end grain, there still will be a nice contrast because the finish will soak into the end grain, tends to go a much darker colour. Drill press is definitely the best tool for this, and if you don't have that, you might want to look into a plunge router jig just so that you can guarantee the straightness of the hole, so you're actually adding some strength to it and not blowing out the sides, because we don't have a lot of wriggle room here. I'll be going with 6mm dowels, but you could probably go anywhere down to, trying to make up a rule to make this work, maybe 1/4 of the thickness of the walls of the box up to half the thickness. So that'd be 3mm up to 6mm in this case, or 1/8 inch up to 1/4 inch for 1/2 inch walls. If it was a drawer, I would say go a reasonable distance down, but as this is a box, it's not really going to be held up by the sides and have that extra force applied to it. So I'm going to go for twice-ish the thickness of the material, so I'll go down 20mm and that should be just fine. I've done some layout on the box to determine where the support dowels are going to go in. I'm going to split off 50mm for the lid and then have 2 dowels on each side of that, so the lid will get 2 pieces, the base will get 2 pieces, and they're 10mm away from where the kerf will be and 10mm away from the edges. With the lid separated from the base of the box, we need to look at how to actually reattach them. Now there are lots of different options. Of course, we could go for hinges. I'm not going to cover hinges in this episode, as I feel that hinges really deserve an episode of their own. Looking at several of the different types and why you might go for box making hinges that are quite expensive versus big box store hinges, the different quality, that sort of thing. Instead, I'm going to go for a similar approach to this hex box I made in episode 1 of the Big Box Bonanza, where it has a little lip on the inside to index the lid on. Now in this example, I created a rebate before glue up. It was on the inside. I messed a few things up, but the theory worked quite well. For the pinned rebate box, instead, I'm going to add what's called a liner, which is some material that goes on the inside of the box. Because it'll be attached to the inside of the box, that naturally indexes really well on the inside of the lid as well. It stops everything from rattling around. There are no real hard and fast rules for the liner material or how you go about it. Going for miters on both ends. Ideally, you'd be shooting this with a shooting board. I've just done this on the table saw, and it's a little bit looser fit than I'd ideally like, but that's a lesson for another time. The material, I've gone for the same material as the base, so this is Jarrah all round, and this will contrast with the outside of the box. It creates a nice little visual detail. This is about 6mm thick material, and it sticks up from the sides by about 7mm. You can probably go up to about 10mm tall. The taller it is, the more effort it'll be to get the box lid on and off, which may or may not be a good thing. So just keep that in mind. The overall thickness will not really affect anything else, just the total volume you've got inside. You can rebate these rather than miters, but miters will tend to push everything out, and that's a good thing because if you get this tight enough, you don't actually have to glue it, and each of the pieces will hold the other pieces out. Unfortunately, as I said, I didn't get this quite as tight as I would like, so I will be gluing these in. A bit of glue on the outside surface here will make it mesh nicely, and it'll be rock solid. Quite a bit I like about this box, and we'll get into what I don't like in a moment. The pinned rebates go together so quickly if you're not filming, as an afternoon project type thing, because they just go together so quickly that there's not a lot of fussing around getting a perfect joint because it's such a basic joint. Though they're not hugely contrasting, the end grain showing off the dowels. It's still a nice little detail, and I love splitting boxes at the table saw because you can see a seam when I've got the video light shining on it, but it is fairly invisible. Also, I love the contrast with having a liner in a box. Just adds something. Though for some boxes I definitely would prefer hinges and might be compromised by having the liner down a little bit lower, so hinges will still work. This is probably where I'm most disappointed with myself in the box construction. The joints on this liner are just not very good. But by talking about what I haven't done well, that's something I can work on in the future and hopefully grow as a woodworker. It's better to make something and make a mistake so that you can learn from it, rather than making something theoretically perfect but never actually going through the iterative process of learning and getting it right. As I said, I'm fairly happy with how this has turned out. This will go onto my desk and hold a bunch of stuff, I guess. But if I'm being perfectly honest, I don't think I'd do more pin rebate boxes. I'll use them for drawers because they're really great for drawers. But for boxes, they don't provide anything that other forms of joinery do provide, while also not looking quite as good. A mitered box, for example, is about the same strength once you put a spline in it, but you have the lovely grain wrapping all the way around, which looks great. And on this type of box, it's interrupted by that rebate showing. You've got more strength in dovetails and box joints, and I find those type of joints are more interesting, more visually appealing anyway. So I'm not really sure, other than the time that this takes, what advantages that a pinned rebate has that I'd necessarily go for. But if it appeals to you, I think that's the wonderful thing about woodworking and crafts in general, is that you do you. You make the thing that appeals to you because you can. I'm really pumped up for the next couple of boxes that I've got planned, and the projects associated with the boxes, the tools for making the boxes, I suppose. So hopefully stay tuned for those, and thanks for watching.